Hi everyone! In this video we're going to be talking about the properties of parallelograms with example problems. The first property of a parallelogram is that both pairs of opposite sides are parallel. Remember, parallel means the same slope and that they do not intersect. So the opposite sides, AB, is opposite of DC. And to show parallel, we put these arrows in. So AB is parallel to DC. That means the other pair of opposite sides are also parallel. So AD is parallel to BC. Both pairs of opposite sides are parallel. Next, we have opposite sides are congruent. Remember, congruent means exactly the same. So AB is congruent to DC, and I put in the congruence marks. So AB has the exact same length as DC. AD is opposite of BC, and they both have the same length. So AD is congruent to BC. Opposite sides are congruent in a parallelogram. Next, we have opposite angles are congruent. So angle A is opposite of angle C, and therefore they're congruent. They have the exact same measure. And angle D is congruent to angle B. They're opposite of each other, and they have the exact same angle measure. Opposite angles are congruent in a parallelogram. Next, we have diagonals bisect each other. First, let's identify diagonals. So diagonal AC and BD. And remember the vocabulary word bisect, that means it creates two congruent parts. So for example, where they intersect the diagonals, we'll put a point E. So the diagonals, by intersecting, they create two congruent parts. So AE is congruent to EC. And DE is congruent to BE. Diagonals in a parallelogram bisect each other to form two congruent parts. Next, we have a diagonal divides the parallelogram into two congruent triangles. So, for example, AC is a diagonal, and that forms two congruent triangles, triangle ABC and triangle ADC. So triangle ABC is congruent to triangle ADC, meaning if the two triangles are congruent, they have the exact same side lengths and the exact same angles inside. And this is with diagonal AC. But if I were to form the other diagonal, which would be BD, I would have two other congruent triangles. Triangle ADB would be congruent to triangle BDC. A diagonal divides the parallelogram into two congruent triangles. Next, I have consecutive angles or supplementary. When you see this word consecutive, that means adjacent or next to. And remember, supplementary, I can turn the S into an 8, and that means they add to 180 degrees. So let's talk about consecutive angles. Angle A is consecutive to angle B, meaning if I add angle A plus angle B, that's going to equal 180 degrees. Angle B is also consecutive to angle C. So angle B plus angle C is equal to 180 degrees. Angle C is consecutive to angle D. So angle C plus angle D is equal to 180 degrees. And angle D is also consecutive to angle A. So angle D plus angle A is equal to 180 degrees. Consecutive angles, which are angles that are next to each other, add to 180 degrees and are supplementary. Now let's look at a few examples where we can apply the properties. So number one, in parallelogram QRST, QP is equal to 2x plus 4. So let's write that in. And RS is equal to 3x minus 15. Find QP and RS. So the property that we're going to be applying to this problem is that opposite sides of a parallelogram are congruent. Congruent means they have the exact same length. So that means I'm going to set QP is congruent to RS. And if they're congruent, then I can set 2x plus 4 is equal to 3x minus 15. Get the variables on one side, so let's subtract 2x. 4 is equal to x minus 15. And then let's add 15 to both sides. So 19 is equal to x. Now notice in the question, it wants us to find the length QP. So I need to substitute 19 back in. So 2 times 19 plus 4. And you can put that right into your calculator. And I'm going to get 42. And when I do the same thing to RS, I should also get 42 since they're congruent. But let's check just in case. 3 times 19 minus 15. Again, put that into your calculator, and you will also get 42. Opposite sides of a parallelogram are congruent. Next, number 2, in the diagram below, parallelogram ROCK, measure angle C is equal to 70, and measure of angle ROS is equal to 65 degrees. Find the measure of ORK. So let's identify where ORK is. ORK, which is here. Now, remember, in a parallelogram, opposite angles are congruent. So if this is 70, then this also has to be 70 degrees. So the measure of angle ORK is equal to 70 degrees. Opposite angles are congruent in a parallelogram. Number 3. In the accompanying diagram of parallelogram ABCD, diagonals AC and DB intersect at E. AE is 3x minus 4. Always label your diagram. And EC is x plus 12. What is the value of x? Notice that diagonals bisect each other. Bisect means creates two congruent parts. So therefore, AE is congruent to CE, meaning I could set them equal to each other. 3x minus 4 is equal to x plus 12. So let's get all the variables on one side. 2x minus 4 is equal to 12. Add 4 on both sides. 2x is equal to 16. And then divide by 2. X is equal to 8. And notice this question is just asking for the value of x. We do not have to substitute back in. And always verify that and reread the question again. Number 4, if measure of angle Q is 5x minus 7, so let's label 5x minus 7, and the measure of angle P is 2x plus 5, find the measure of angle Q and the measure of angle P. So remember, adjacent angles or consecutive angles, angles that are next to each other, are supplementary, meaning that they add to 180 degrees. So I have to take 5x minus 7 plus 2x plus 5 and equal it to 180 degrees. Combine like terms, so 5x and 2x, so that's 7x. And then negative 7 plus 5 is negative 2 is equal to 180. Add over the 2. So I get 7x is equal to 182. Divide by 7 on both sides. So 182 divided by 7 is 26. X is equal to 26, but remember, I have to substitute back in. So for the angle Q, 5 times 26 minus 7. Again, we put this in our calculator. 5 times 26 minus 7 is 123. And then angle P is 2 times 26 plus 5. Again, put it in your calculator. And that should be 57. And if I add 123 plus 57, I should get 180, which I do. So the measure of angle Q is 123 degrees, and the measure of angle P is 57 degrees. Adjacent angles of a parallelogram are supplementary.